Hi everyone, we're carrying on with the shared coordinates tutorials. This one follows on from the first one where we saw how we could coordinate some points that were measured afterwards in the field to a CAD file as long as they were referenced to the same beacon. In this tutorial we're going to see how we typically handle the CAD data as well as a Revit topography to link that into an architectural model and to acquire the shared coordinates so we may then share that with other disciplines as well. This is the file, the CAD file which has been changed. The previous one was very much 3D. You might recognize that from the last tutorial. And that is now only showing the relevant geometry with reference to the origin. So if I zoom extents, it just shows me the information that I need. I'm going to create, remember that the points are, that's the center of the ranges of the X and the Y values of the points that were measured in the field, and we coordinate these two with each other in a topographical model. So I'm creating a new project in Revit from the architectural template. I go into the site plan. Just want to make sure that my view range is set appropriately. That can be unlimited. Yes, that's okay. And what I'm going to do is I'm going to insert the CAD file first of all. So I'm inserting and linking in the CAD file. It will be the second one over here. Colors preserve all, millimeters, yes, that's all good. By shared coordinates, no, I'm going to place it manually by base point, and I bring, sorry, I can actually bring that in center to center, but there we go. It's simple now, just to move it into place, move the intersection of those yellow lines and snap to the endpoint over there. So that is now perfectly in place. It's a two-dimensional CAD file, so it's perfectly flat. Let's have a look at that in 3D. You'll see it's perfectly flat. Basically showing the outline of the property with reference to the beacon. I can lock or pin this in place so it doesn't move, and then I create on my massing inside a topo surface from import. It's a points file that we created also in the previous tutorial there, or blog. There is millimeters, and it goes and creates the topo surface. I know that is correct, and that is fantastic. That's good. All right. We also want to make sure that the contours are labeled appropriately. So one of the things we should watch out for is that the family showing the contours is referenced to the survey point, and also in the elevation view that the levels are also reporting the survey point. So if we edit the type and we change the project base point to the survey point, there we go. Right, so that is as far as we really need to go right now. And now we need to set the coordinates. Now there's two ways to do it. The one is that you can assign, you can specify coordinates at point, which means that you'd be able to specify the value for these ordinate lines, latitude or longitudinal lines. The alternative, and that is the most common one, is that we use the CAD file's coordinates. So we just say acquire the coordinates. Let's just make sure that we can see the markers, then you can see what's happening. We can acquire the coordinates from the linked CAD file. And immediately what you'll see is that the survey marker moves all the way out to where the origin used to be in the CAD file, where the origin is. So this beacon is now sitting right on top of the AutoCAD 00. It's a bit tricky because now if you zoom extents, it zooms all the way out of your model over there. So a nice neat tool that they have is that if you unpin it, you can move it back right on top of the other marker. It's reporting different coordinates, so that would then be the same as the middle of the X and Y ranges. It's just displaying the annotation separate from where the actual marker is sitting. And then clip it. The other thing we need to do is to relocate the topography, because it is in fact sitting in a higher elevation. So in an east elevation, we can relocate the project by the minimum Z value. Remember, that is the minimum Z value that we corrected the Z value by, so that we could create the surface around the project internal 0 point. There is the relocate project, and that would be a distance of 1494000, 1.5 kilometers. Zoom extends. There it is showing me the elevation. If I had to change back the elevations reference to the project base point, it will show 0, which means U1 is now modeling still around the 0 point of Revit, the project internal point, and it's just reporting with reference to the survey marker. So the project base point will report the elevation correctly. Okay, this file is now correct, and we can save this file as our topographical model. Yes, we want to replace it, and then we can close this file. That is now ready for us to share into our architectural model. So looking at our architectural model, there's no coordinate system or anything assigned to it. It's just a straightforward model that was drawn around the 0 point in Revit, or most people would. And we can now link in let's first get the Revit link in the topography, and I'm going to go origin to origin for now and open. So the project internal base points will now correspond to each other. I can see immediately that my view range on this is set incorrectly. Let's fix that. Unlimited above the ground, cut it at a very high height, and there I can see how it is with respect to the house or to the building, and it's not exactly right. So what we need to do is to move the topography relative to the building, and that is what we do now. So let's suppose that I know that the building must be at some other point, and of course one could do this with a CAD file also to get it into position. One can even do that a little bit later, but there it is. One can rotate. Rotate the topography a little bit. We'll see how this view is showing true north orientation at the moment. And That is of course of the building project, not of the topography. And then we also need to fix the elevation. So that is probably going to be where we want to look at the elevation. We want to move the linked file down some. What we're going to do is move this downwards a little bit, say from this point here down somewhere around there. Let's have a look in 3D. What does that look like? Yeah, it's not too bad. Alright, so that is something that one can perhaps contemplate. That is a good solution. And then what we can do is to say, alright, now I want you to accept the coordinates of the site. Let's pin the site. It's good, then we can't move it around anymore. And then in our manage, we acquire the coordinates of the link. Automatically, it will move out the survey marker again. Once again, we can just unpin that, move it back into so pin it, clip it. And now, since we've accepted the coordinates from that file, it's an easy job to link in the CAD file. Colors preserve, it's millimeters. We're going to position it by shared coordinates, and we're not going to orient it to ground, to the view, otherwise it would rotate it. And we say open. And there we can see what that site is looking like. So because we are using shared coordinates, the CAD file is coming in automatically correctly oriented with respect to the topo file that is coming in. And from here onwards, it's going to be a very simple matter now to share that with the other disciplines. Let's save this file. Also note that the links are set to be relative. And in the case of the Revit links, they're set to overlay as opposed to attachments, so that one doesn't load a file twice into another one. So does this work in reverse? If we open the topographical file, can we bring the model in correctly now? And the answer is yes. There is the topography. There we can see the topography. And if we insert and link in the Revit file, for the architectural model by shared coordinates, will automatically place that in the correct position. That CAD file is of course now out of position. Let's just get that back in by shared coordinates. We link in the CAD. Also by shared coordinates. That's great, that's easy now. Okay, so one can go in reverse just as easily. Which in this case, what we want to do on the site level is just place a, let's go to level 1, site elevation, and we can just move that into position. That will now be coordinated with the one more. It's level 1. And this is on this level. I want to create just quickly a building pad that will serve massing in site, creating a building pad which can then be incorporated into the site drawing. So if one has more than one building, one will be able to do cut and fill schedules. Maybe there are many buildings, similar buildings, that one would like to incorporate into the site. Then one could always use the ability to show the cut and fill that is expected to occur on the site. And finally trimming that into corner. There we have it. Accept. All right. Let's go and have a look what this looks like in the architectural model. We can save this. We can actually discard the links. And there we can see the building pad for our model. Of course, if we open the architectural model, we can see how the building pad is now also correct. Thank you very much for your time. I hope that you've enjoyed the blog and that it will be helpful to you in the future.